Hey, good morning. Am I audible? Good morning, everyone.
Good morning, sir.
Today we'll going to discuss about the battery performance, right? That is regarding the capacity. That is the battery how it is going to charge and discharge, C rate also, and capacity and degradation of the batteries. Right. This is the today's agenda. The contents are in the battery technology chemistry. We are going to study the performance parameters, its charging, discharging, C rates, its capacity, and how the battery gets degraded and lifespan will over for the most of the batteries. So right, if you see the characteristics of batteries are fully defined by the set of parameter battery parameters. That is what I told. We have to think about the parameters such as charging rate and discharging rates and the C rates and also the capacity and how the batteries is going to degrade and it's to give the life for the entire for more 5 to 6 years. Right. Let us see its performance, how it will going to perform the all the most of the batteries. Right. So parameters includes the charge storage, right? How it is going to, how much of amount of it is going to charge the energy, its capacity, and the what is the terminal voltage when there is a load is not connected with respect to the internal resistance of the batteries, and also the rate at which the batteries can be charged and discharged. The cost, how much of cost of effective for the batteries would be there, and the number of times the charging and discharging of the life cycle. The life cycle which depends upon the how much it will charge and how much it will going to discharge. These are the various parameters we have to discuss in the today's class. It can be carried out for the charging and discharging of the batteries can lifetime and so on. So how much number of years it can provide the life for the by making the charging and discharging of the batteries, right? So ideally we would like to discuss more about the work, how many years it can give the life for the batteries, and also how much required energy is required for in various conditions while charging and discharging of the batteries. So based on all these parameters, we shall the manufacturer has to think more about the various parameter before going for the selections of any batteries. Right. So these are the battery parameters of specified for the most of the manufacturers. The terminal voltage, that is a open circuit voltage. We have to see the terminal voltage which is connected across the loads. We have to see how much of it is going to discharge towards the loads, and the charge storage in terms of coulombs, right? That is in terms of ampere hours. Yesterday we had discussed about the ampere hours. How much of amount it will try to discharge, how much of current it will discharge in a specific time periods, that is for 1 hour, 2 hour, 3 hour, like that, right? And also the depth of discharge. So in terms of percentage, like it may be of 80 to 90% or 60 to 80% will depends upon the depth of the discharge of the batteries, and also the number of cycles. That is the number of cycles. It may depends upon 5,000 cycles, 3,000 cycles. Based on that, it can give the year of lives. Right? That is life in the years can also be predicted. And also the self discharge. That is self discharge rate. We already discussed in the previous classes. That is 1%, and the life efficiency would be the 95%, 85%. Self discharge may be of 1 or 2%. So like that. So battery terminal voltage, that is which tells about the energy transfer from battery to the load. How much possibilities of energy can transfer from the battery to the loads when there is a voltage difference between the two positive and the negative terminals. Right, the battery terminals voltage is the voltage which difference between its two electrodes, that is anode and cathode electrodes, right? The voltage difference between the battery terminal is driving force to flow the charges, right? If we consider for the PV system, right, for PV system application, we are going to use the batteries which are available for in the market of 6 volts and 12 volts, which are connected in series and parallel to make the battery pack and the battery module also for the energy storage of the from the solar panel to the energy storage batteries, right? So each battery is usually made up of cells. The cells will be arranged in series and parallel to get the more current and less voltage, more voltage and less current. It depends upon the series and parallel combinations, right? So normally the cell voltage is not larger to give up to the required of 6 volts or 12 volts, right? So 6 volts, if you connect the batteries in series, the voltage will get more, right? If you connect in parallel, the current will get more, right? So that is the reason the cell voltage will have around of 6 volts to 12 volts for making the arrangements in the series and parallel combinations to get the higher voltage and the lower current and higher current and the lower voltage. That is what we make the connections for the batteries, right? So here the battery terminal voltage can change with the conditions of the batteries, right? So battery voltage will not remain. So every 6 volt means it may give 5.8 volts also. It depends upon the degradations and the life cycles of the batteries. Right. So if we talk about the battery terminal voltage, it changes with condition of the batteries. When the battery is during the charging, the temperature will may also increases. We have to consider the parameter of the temperature. If the temperature rises in the batteries, there is a chances of degradations will be more, right? And the life cycle will also be it is about to finish its life. If the temperature get rises to more than a certain temperature, like 40 degree, 48 degrees, the life of the batteries will also be degraded very soon. So that's why the battery terminal voltage also will depends and based on the conditions of the battery. That is the parameters which relevant to the batteries. That is the temperature is most of the parameters which can change the battery conditions. Also, it may change the battery lives also. Right. So that is how the battery terminal voltage will increases when the battery gets charged, and the terminal voltage will decreases when the battery gets discharged. Right. So during charging and discharging of the batteries, the temperature will plays a main roles for the variations in the battery conditions. Right. So let us see the battery open circuit voltage and terminal voltage. The terminal voltage of the battery is the maximum when it is fully charged. Right? If it is charged for 100%, then we say the terminal voltage is around the maximum voltage. Right? When no current is flowing, because in the open circuit voltage, the voltage will be there, there is no current. Right? If we see in the short circuit, the voltage will be less and current will be very high. The condition of the no current flows is equivalent to the open circuit. So the maximum terminal voltage of the batteries is also referred as a circuit voltage of batteries, or V naught. Right? The maximum terminal voltage of the battery is also, we can mention it as a V naught. That is the maximum terminal voltage which is not connected to the any loads. Right? When it is a full when it is a charged, and if there is no current flowing, then the terminal voltage will be V naught. When current flows through the batteries, the terminal voltage is normally lower than the open circuit voltage. Right? When you connect any loads, what will happen? The current will start flowing from the batteries to the particular loads. Right? This is happens because of the internal distance of the batteries. The battery internal distance will have the R values, in which the internal resistance also depends upon the battery various parameters. So due to its own resistance, the sum of the voltage will also drops inside the batteries, right? Usually most of the batteries will be having its own internal resistance, as we have body in our bodies also we have the resistance in our body, how it is going to resist when you pass the current into our bodies, right? So like that we have what we have in the iron content in our body. Same thing, the batteries will also have the internal resistance, right, in which there will be voltage drop across in the internal resistance of the batteries. Also we have to consider this factors also, right? So this voltage drop is which is equal to the current flowing through the batteries, and will be multiplied with the internal resistance of the batteries, which is given by I into internal resistance of the batteries. Right? This is the actually the circuit diagram will look, right? This is actually electromotive force of the batteries, and we have the internal resistance, the R, right? That is Ri is internal resistance, and the drop across this is the I into R, right? The current which is flowing from the battery, there is a drop across this also, and which across these two terminals we are going to connect the our external loads. So right, in this way the terminal voltage can be written as, that is a V battery is equal to V naught, that is a terminal that is open circuit voltage, minus I is the current which is flowing through the loads. The current which is flowing through the, when you connect any load, the current which flows to the load, that we consider as I, multiply with R into I is the internal resistance of the batteries. So this is how the battery voltage can be calculated, with considering the internal resistance drop across the internal resistance, right? We have to consider the drop across this. So that is the current into minus I into Ri. The current over this, and Ri is the internal resistance of the batteries. We have to consider this drop and output voltage. So that will give us the actual voltage. That is based on your Kirchhoff voltage law equations. All right. So the battery internal resistance is shown like this. It depends. The battery has the internal resistance due to the many factors. Most of the factors will also makes a lot of impact in the batteries due to its manufacturing of the cells, right? The factors like the contacts within the cells. It may be of your electrodes, or it may be of small metal plates. So those will have the place important impact on the internal resistance, right? And electrode also, like bridge separators between the two electrodes and electrolytes also, which can create a small internal resistance. So these we all together we consider as the internal resistance of the batteries, right? So internal resistance of the batteries may be considered the metal plates, the electrodes, the salt plates and separators, electrolytes, and these are the various internal resistance of the batteries. So, all right, let us see the terminology of the batteries for the terminal voltage, right? Open circuit voltage, which is also called as a theoretical voltage, because this is the maximum possible voltage at output voltage terminals of the batteries when the circuit is under the open condition, right? So, when you don't connect any voltages, the voltage will be the maximum, right? If we connect any loads, there will be a voltage will be connected across the loads, right? So usually the terminal voltage for our operating voltages, it is actually available in the batteries right from the 1.5, 3 volts, 6 volts, 12 volts, 24 and 48 volts, which is available in the markets. So these are the various nominal terminal voltage or operating voltages in the batteries. So right, the next when you talk about the cutoff voltages, the voltage up to which the load can operate and below which the battery should be disconnected from the load in order to prevent it from the overdischarge. Right. So cutoff voltage is a threshold voltage. It is nothing but threshold voltage at which the load can be operated for the specific voltages. So below that one, for example, if the voltage is around 3 volts, right? Say around the rated nominal voltage is 3 volts. If it falls below that threshold voltage, the battery should be disconnected from the actual loads. So or else what will happen, it will try to get the power from the batteries usually, that is to get the power from the batteries, it will try to discharge or degrade the batteries as soon as possible. So that is the reasons whenever it falls below the threshold voltage, we have to disconnect the batteries from the actual loads so that we can overcome from the degradations of the batteries. Right. This is how the one of the companies which is manufactured. They have shown the battery rating of around 12 voltage. Right. We already discussed the rating of the batteries is 3 volts, 6 volts, 12 volts, 24 volts, and 48 volts. So these are the various standard nominal voltage of the batteries which is available in the market. Right. You can connect this in series to get the more voltages. Alright, this is the actual batteries of the JCB manufacturers, where they have shown the battery ratings of 12 volts and 26 amperes of the current. Right, this is the ratings in which we can have the batteries specifications. Right. So let us see the storage capacity. The battery storage capacity. Battery storage capacity is the capacity to store the charge in the batteries. It is a product of current in the amperes. Okay, Shivraj, am I audible? Okay, Mamta. Solid. Battery storage capacity is the capacity to store the charge in the batteries, how much of energy it can retain while doing the charging conditions, and how much of amount of current it will able to try to deliver to the loads, right? So when we multiply with this various two factors, that is the ampere and the hour, so it will give the rating of the batteries, that is a product of current which can deliver to the particular loads in a specific time. Hence it is multiplied with the ampere hour. The rating of the battery is also mentioned in the ampere hour. So 1 ampere hour is the amount of charge that is delivered when the current constant current of 1 ampere is used for 1 hour. That is we have discussed for yesterday's class. So 1 hour of the in 1 hour how much of current it will deliver. In 2 hour how much of current it will deliver. In 3 hour how much of current it will deliver. In 4 hour is it delivering the 50 amperes. In 3 hour it is delivering the 25 amperes. In 2 hour it is delivering the 15 amperes. So that is how the rating of the batteries capacity can be identified. So that is the capacity is equal to current into multiply with the hours. So if it is delivering the 1 hour, in 1 hour it is delivering the 50 ampere of the current. In 2 hours it may deliver the 75 ampere of the current. So based on the multiplying these two factors, that is the current and the ampere, it will give the value of EH. The capacity can be determined with the EH factors of the batteries. The capacity of a non-rechargeable batteries normally varies in a few milliampere hour to several ampere hours. So that is a non-rechargeable batteries. Apart from the lithium batteries, other batteries will be identified in terms of milliampere hour to several ampere hour ranges. Right, the capacity of the rechargeable batteries can vary from few ampere to 1000 ampere hours. Next, the capacity of the batteries depends on the temperature. As I discussed about the during the state of charge of the batteries, in which the battery is going to be start charging and start discharging, right? So during that instant, the battery temperature will may rise and will lead to the degradations of the battery life also and the C rate also, right? The capacity of the batteries is very important factors if you consider the temperature, right? So when the temperature, when the battery is going to be charged, right? When you plug the for the charging purpose, the state of charge, or what we say the SOC, the state of charge, that is SOC. So during the SOC, there will be the small rise in the temperature in the battery and the battery elements. It will try to increase its temperature, and during the discharging also, we'll make the notice of the discharging time also. The temperature will also try to reduce. The temperature will also try to reduce during the discharging. Okay, all right. The same batteries will have the different capacity, different temperature. So that is what the depends upon the EH of the batteries will have the different temperature. Lower the EH, temperature will also vary. Higher the EH, the temperature will also vary. So depending upon the battery capacity, the temperature can also be monitored. So based on the designs of the batteries by the various manufacturers, we have to see how the batteries can be charged and discharged in a very safe mode condition, so that the temperature can kept a very at nominal conditions, right? The capacity specified at the standard test condition of around 25 degrees centigrade will have the specific state of charge. For 48 degrees centigrade will have the specific state of discharge. For various temperature we can have the state of charge and state of health conditions. We can monitor the battery health conditions also. Right, hence the capacity will all value measured at the installation sites may vary from the values given from the manufacturer because of the change in the temperature at the particular location. If we carry the battery at the different regions, so we'll have the different temperature. So based on that, the charging and discharging will also makes a lot of impact in the for the batteries, right? Because if you take the batteries in the other regions like Shimla and wherever the temperature is very less, the degradations of the battery will also um, makes a lot of impact on the battery health also. So that's why you have to focus more on the temperature conditions. Is a very important factors to take care of the batteries for the life cycle of the batteries. We have to see whether it will give the life for more years, whether it will give the life for less years. Everything is depends upon the temperature. If the temperature keep on rising, the degradation will also rise very soon. So with respect to these factors, we have to see the battery condition, the battery life. So which is based on the temperature of the batteries. Right, while selecting the batteries for any given purpose, please look after the temperature of the locations also and should be taken into the accounts, right? So here in our state, the temperature may be very moderate. In other state, if you go to the other state, the temperature will be very high. Especially in the if you go to the West Bengal, the temperature will be around more than 42 degrees centigrade. If you go to the other state of where the temperature is very low in the Shimla, the temperature will be very low. So based on the regions, please try to select the battery mm, ratings and also the battery purpose, for what purpose you're going to use it. Right. So this is actually the battery capacities where we are going to see what is the battery capacities of the ratings of the batteries. What is the battery capacity? When you talk about the battery, what is it? 10 Ah, 5 Ah, 50 50 Ah. Okay, Shivraj, am I audible?
Yes, sir.
Mamta,
Hello, sir. Audible, sir. Audible.
Mamta, Salman.
Yes, sir, you are audible.
So is this visible, Shiraj? Shiraj, is this visible to you? the data. Okay, all right. These are the various data which is collected from the battery cells, right? You can observe for a specific time, right? And the current is around, this is a current at 2.15, the voltage is 2.99, the temperature is around 26 degrees centigrade. So these are the various current and the voltage levels where we have to see the temperature also, right? If you when you charge the batteries, when the battery is going to be keep on charging with respect to the temperature and the time also, you can see there is a rise in the time, rise in the current also, and the rise in the voltage also. With respect to this, the temperature is also rising very gradually. Sometimes it is decreasing, sometimes it is increasing. So that is what we have to monitor the temperature also, and the specific temperature. If the temperature limit is around 25 degrees centigrade, please try to monitor in that level, so that if the temperature rises during the charging, the battery life will also degrade very soon. So that is why this data, I'm just showing this data to make you to understand the actual degradations of the batteries, right? So how you have to maintain the battery's temperature. If you don't maintain the battery temperature, the degradations will happen very soon. So that's why we have to see how the batteries can be monitored in the specific during the charging and discharging, right? So these are the various data we have taken for the analysis purpose. So likewise, we have the various current temperature also, which is going in the negative values, and current the voltage is around 3.37, the temperature is around 26. So from the 25, the temperature has been raised little bit to 26 degrees centigrade. You can observe the various temperature and also the various voltage levels, the battery conditions of the cells, right? Each cells will have comprises of the various factors. When the rise in the cells temperature, the current will also increases, the battery temperature will also increases gradually. This is the one factor we have to see for the C rate of the batteries. All right, this is actually data which has taken for to do the research for the specific cells, right? As I shown the values of the cells around 3 volts, 6 volts, 12 volts, 12 volts, 48 volts, right? So we have studied for the particular cell ratings for around 3 to 6 volts, how the temperature can be raised. So these are the various data which is available for us to make the research and study the state of charge and state of health of the batteries, right? For the specific purpose for the degradations. All right. So this is the various data I have collected from the around more than 500 data have been collected for the study analysis. See, every time we are going to monitor the same temperature, which is to be around 25 degrees centigrade for a particular value of the voltage and the current, right? So you can see the temperature is almost 25 to 26 degrees centigrade during the charging and during the discharging of the batteries. Right. So you can just go through this. You can take the screenshot of this data. It will be very useful for the analysis purpose for the degradations for you people. They have taken more than thousands of data sets has been available, uh, which you can use to monitor for the battery. Every time you can see there is a temperature, the small rise in the temperature of around 25 to 26 degrees centigrades. Right. This is analysis which is made for the battery state of charge and monitor the health conditions of the batteries for the degradation purpose. So right, this is actually data sets. Okay, if you want to have, you can take the actual data set for the analysis purpose for the future use. Okay, all right, we'll get back to our PPTs, the battery capacities. Okay, okay, we'll current slide. Okay, all right. The battery capacity, right? What is actually the definition of the battery capacity? It is the amount of electricity which will be generated by electrochemical reactions in the batteries, right? So during the charging, during the charging of the batteries, it will try to generate a certain amount of energy, right, which will require to deliver the energy to the loads, right, by the chemical reactions. We discussed in the earlier of the photovoltaic cells to the battery, the chemical reaction, how the chemical reaction will happen in the previous sessions, right? So electrical charges can be converted to the electrical energy will be converted to the chemical energy, and chemical energy is again converted back to the electrical energy. So that is the energy, how much of total amount of energy can be generated, right, by the chemical reactions. That defines the battery capacities. All right. So there is massive active materials contained in the batteries. Based on the types of the materials you are going to use in the inside the batteries, based on that the battery capacity can be rated. Okay, now let us see what is the C rate actually. I was discussing, focusing more on the C rate, right? The C rate tells about the capacity of the battery rate, right? It depends upon if it is charged for 100% and what is the C rate. If it is charged for 80%, what is the C rate? If it is charged for the 70%, what is the C rate, right? So it is used to measure the speed at which the battery is to be discharged, right? So when battery is charged and discharged, we call it as a C rate. So if the battery is charged for 80%, then we say call it as 80% of the battery has been charged, right? It is the amount of measure at which how fast the battery can be charged and discharged. So that we call it as a actual the C rate. C rate will defines the at what time at what measure the values of the speed the battery can be try to charge, and how faster it can discharge, right? That defines the C rate. The C rate definition will tell us about the it is used to measure the speed at which the battery is charged and battery is discharged. All right. Now you can see from this image, the C rate will tells very clearly that charging at a C rate of a 1 coulomb. So as I told during the charging of the any batteries, it is the total amount of charges which will be stored in that is the electrical charges which is stored in the batteries for the specific time, and it will try to discharge also, right? So if it is charged in, it is taking a time for 1 hour. For example, the battery is taking for 1 hour. It will take 1 hour to charge fully, right, for 100%. Then we say the C rate of is one say charging at the C rate of 1 coulombs, right? If they are taking for same battery, other batteries is taking you 2 hours to charge the 100%, that is fully charged for the 100%. Then the C rate will be the different. Okay, C rate will depends upon the type of how much of amount of charges been stored and retained in the batteries. All right. So that is how your battery uh, can be identified. The battery rates can be identified. Uh, sure, it is clear to you? Okay. Okay, that is what it will define the C
Yes,
rate.
sir.
Anyhow, Shiraj, I'll be explaining in the evening classes, so don't worry. We'll go through the
Okay.
various types of the graphs to understand the charging and discharging rate. We'll study the state of health, state of charging, state of monitoring of the battery's health also, and how the C rate can be defined with the specific graphical methods. Right, we'll make the analysis. We'll try to understand in the better way in the after evening session classes. Okay. So here I'm just
Okay.
giving the introduction part so that we'll understand the terminal voltage, the various parameters in the batteries, the cost of the battery, the C rate, right? So these are the things we'll try to analyze in the today's sessions. All right. So as I told, the charging at the C rate of 1 coulomb is nothing but how much amount of the charges can be stored in the batteries for specific time. If it is store the maximum amount of charges for 1 hour, then 100% of is full. It is then we can say it is fully charged, right? Sometimes it will take 2 hours to store the charges, right? For fully charged 100%, if it is going for 100%, then it will take the 2 hours. 2 hours of the charges it will take. So that is how the C rate can be defined actually, right? So here the C rate will specify very clearly, right? As I mentioned, here on the left side, you can see there is the slow charging of the batteries it is happening, and the right side you can see there is a fast charging of the batteries can be happen. It is nothing but it depends upon the how much of coulomb of charges can be stored in the batteries, right? You can see there is a fast accelerations over on the right hand side, and the left hand side we have the steady driving force of the charges which can be stored in the batteries, right? So for example, if it is taking up 1 hour, then you can say it is 1C of the C rate. The C rate is 1C, right? If it takes 5 hours, if it takes a 5 hours to store the charges in the batteries, right, then we can say it is a C by 5 times. C by 5 times. It is taking the 5 hours to charge the batteries, right? Similarly, when you talk about the 3C, right, in the 3C the time is taking very less. That is a 20. It is taking the 20 minutes of time to charge the battery. That is a quick charging. It is happening over here, right? So that is what during this time you have to focus more on the or the battery temperature, right? As I'm discussing about the given the data for the in the Excel sheet, right? I've just shown the data from the Excel sheet. We have to monitor the temperature also. Focus more on the temperature, because temperature will give the life for the batteries. If the temperature increases in the batteries, the degradation will happen very soon. So that is what, please try to focus more on the battery life. So all right, so this is the one things as I shown in the Excel sheet of the data. You can see just we are just maintaining the 25 to 26 25 degrees centigrade for all the thousand of data I have taken for the analysis purpose, right? At least almost you can see in my this Excel sheet, the temperature is almost in range of 25 to 26 degrees centigrade, where it is not going to be increase every times, right? Because I have considered the more than thousand of data. See, this is the actual data which has been collected for the analysis, right? It is almost 25 to 26 degrees centigrade, right? So that is how you have to maintain the battery temperature. The battery temperature maintenance is very important, so that the degradations can increase the life also. Degradation can be, we can work upon the degradations also. The life of the batteries can also be improved in a better way. Right, this is the data I've shown to make you to to understand very clearly of the C rate and also the battery life. So all right, so this is the actually the your the C rate, where the C rate will happens based on the whether the time taken for the charging the battery it is more or less, right? So if it is taking is very lesser time, then the battery will have the fast charging. If the time is taking more for 10 hours to charge the same amount of charge, right, then you can say it is a very slow charging, right? So sometimes it depends upon the designs of your cells, right? How you design the cells, how the internal resistance will act for your charging during the time of the charging, and the chemical reactions. So everything will depends upon the storage, and also the depends upon the actual charging and discharging time. The various factors will make a various impact on the this batteries, right? And also it will finally it will tells about the degradations of the batteries, whether the how much life it can give, whether it will try to give for one year, try to give it for 4 years, try to it give for the 5 years, try to it will give for the 6 years. It depends upon the battery life. That is what we have to see. The C rate, is very important. So that is how much of charges can be stored in a specific time limits, right? These are the various example I have given for you to make you to understand very clearly for the fast charging and the steady state driving of the force of the charges, right? That is the slow chargings, right? So this is actually, if you see the 4C, the time is very less. It is charging in a 15 minutes. That is, we call it a very fast charging, right? If you come on the right hand side, if you come on the left hand side, there is a C by 10, right? For the same amount, if you take electric vehicle, right, so electric vehicle will take a very long time to charge. So because of the steady driving force and also the slow charging rate of the batteries, so during that time also please try to focus on the temperature of the batteries, because temperature of the batteries has to maintain a very constant, right? It should not be increased or it should not be decreased, right? You have to maintain if the temperature, nominal temperature is around 25 to 26 degrees centigrade, then please try to maintain the temperature during the charging and discharging, right? Temperature should not be increased. If the temperature increases, the life of the cells will go very soon. So once it is life is gone, you cannot recover back of the life, isn't it? Just like the how the people's been having their life for the survival, right? To monitor their health conditions. Similarly, we have to monitor the our health conditions of the batteries also with respect to the temperature. So temperature will plays a vital role in the battery's life. Okay. So actually, this is the things where we have to focus more on the battery life temperature, right? Temperature is a major factors. Please focus on the temperature and try to monitor the temperature also, so that the battery life can be improved in a very faster way, right? If you increase the temperature, suddenly there is a drop in the charging and discharging will happens, and the battery life will also degrade very soon. The battery can go its life as much as possibilities will be there for the life of the batteries also. So please try to look after the battery conditions and the C rate also. So I'll try to wind up the classes for today's sessions. If you have any queries, you can ask me. Yes, Shuraj.
Yes, sir.
If you have any queries, you can ask me.
No, sir. No, sir. No.
Have you
Thank you.
understood the C rate?
Yes, sir.
Okay, okay, fine. We'll continue the sessions for the in the evening. Okay.
Okay, sir. Thank you.
So I'll wind up the classes. Thank you.
Okay, sir.